Okay, so this is question 7 of this day 8 of the Stats Pass program, and this involves a bit of selecting some lollies from some bags and putting them on the bag. So let's just draw out what we've got. So in Susan's bag here, she's got 12, I'll say n equals 12, she's got 12 sweets, 7 are chocolates and 5's are toffee. So 7 chocolates, so 1, 2, 3, 4, 5, 6, 7, and 5 toffees. There's my 5 toffees. And Ahmed also has a bag of sweets. Let's put his over here. He's got 3 plus 4 plus 2, so 9 in his, so n equals 9. And he's got 3 chocolates, 4 toffees, and 2 boiled sweets, so I can call them B. There you go. If I was more creative, I would have found images for you and put them in the bags, but alas, I've just written out letters. Cool. So let's do this up. So we're going to go for a probability tree, and I'm going to go for so Susan's bag first of all, and what she selects. So she's got 2 choices there, either a chocolate or a toffee. So let's do that first. So the probability that she chooses a chocolate lolly is going to be 7/12. Probably that's a toffee lolly is going to be 5/12. So that's okay so far. It says then whatever that sweet is taken and it's put into Ahmed's bag. And then 1 is taken out of Ahmed's bag. So if we go with this one here, if we take this chocolate here, then that's going to be put into Ahmed's bag. And then 1's going to be drawn out of that. So we've got 3 options in Ahmed's bag. We've got chocolate, we've got toffee, we've got hard-boiled. Same thing down here. Okay, so if we go along this route here, a chocolate's been chosen, it's been put into Ahmed's bag, which now means there's 4 chocolates in there. And there's now 10 lollies because you've added 1 to the bag. So it's going to look like that, and 2/10. And then down here, if we take a toffee here and put it in there, there's now going to be 5 toffees out of the 10 that are now in the bag. Okay, so that the first part there is setting up your tree. And I'm using fractions because, although the 10ths are quite nice fractions, the 12ths are not particularly nice, and so it's going to be more accurate to leave it as fractions rather than dividing it into decimals and whatnot. Cool, so for part 1, find the probability that the 2 sweets taken are a toffee from Susan's bag here and a boiled sweet from Ahmed's bag there. So we're just going to multiply across the tree to get the answer for part 1. So 5/12 times 2/10, which equals 10 over 120, which equals 1/12. And you could put that as a decimal, but 1/12 is, I guess, the most accurate way to put your answer. Okay, so on to part 2, which is a conditional probability question. It says, given that the sweet taken from Ahmed's bag. So what I should do, actually, make this really clear, is sort of like I put stages above my branches. That's Susan's bag there, and the second one here is Ahmed's bag, right? So given that the sweet from Ahmed's bag is a chocolate, which could be there or there, right? Find the probability that the sweet taken from Susan's bag was also a chocolate, so there. So this is a conditional probability. It looks like this. You want the probability of both over the probability of the condition, okay? Or the probability of A and B all over the probability of B is what you'll see on like formula sheets and so forth. So if I just move that up for a second, it's not really going to work. Maybe if I make that smaller for a second there. There we go. Yeah, so the probability of both. So the both would be that it is Susan's bag is a chocolate and Ahmed's bag is a chocolate. So that's that one there and that one there would be the probability of that. That's the probability of them both being a chocolate. So that's going to be 7/12 times 4/10. You'd work that out, and then you divide all of that by the probability of the condition, which is just that the second chocolate, which is Ahmed's bag, is chocolate. So if I put that in blue, that's that, but it's also this scenario as well here. So that's going to be 7/12 times 4/10. But you're going to add to that also 5/12 times 3/10. Okay, and if you work that all out, I'd do the numerator of the fraction first and work that out, then do the denominator of the fraction and work that out, and make sure that you're using BEDMAS for that. You're going to end up with 28 over 43 as your final answer. Oops, can't really read that very well. Okay, so that's part 2. And then for part 3, they want you to do this random variable x, which is the number of times a chocolate is taken. So what you want to do is first of all drop your table. So x is the actual outcome, and then your probability, capital X equals lowercase x, is the probability associated with that outcome. Okay, so if you think about the different outcomes there might be, you might be able to choose no chocolates at all, maybe 1 chocolate, and you could end up choosing 2 chocolates, because at this stage you're only choosing 2 of these in total. And then all that's required now is for you to go through and use your same tree to fill out the probabilities. And the good thing about a probability distribution table, a really good trick, is that actually you only have to work out 2 of them, because the third one you can get by just subtracting the other 2 answers away from 1. Okay, so that makes it a little bit faster for you. And sometimes it's when you look at this, it's kind of easier to know which one to start with. For example, getting 2 chocolate, you've already worked that out over here, the 2 chocolate ones here. So 7/12 times 4/10. So straight away you could just add that onto your table, and you can leave them as fractions. So you can leave it as 28 all over 120. Or I guess it would be better to simplify that down. I'm going to start by just doing the whole fractions, and then we can simplify the fractions afterwards. So that's 28 over 120. And then probably easier to go with maybe none of them being chocolate, which means you don't have to worry about this branch here because that involves chocolate ones, right? And then you don't want a toffee and a chocolate because it's a chocolate. So you only want a toffee and either another toffee or a boiled sweet. So you could add those 2 together. That's 7/10 chance of it not being chocolate here. So that means for no chocolate will be 5/12 times 7/10. So 35 over 120. And I guess the advantage of leaving it without simplifying it at the moment is that if you know that everything adds up to 120ths, then you can easily work out what's missing for the middle one, which would be 57 over 120. But what we should do is write our answers in the simplest form. What you can do, if you use the ABC button on your calculator, it'll reduce that down for you. So for example, that one reduces down to 7/24. I don't think the next one will reduce down. Oh, it does. Whoops. 19 over 40. And the last one, if I do 28 ABC 120, I get 7 over 30. Cool, and then we're done.